Hi, my name is Nurul Balkis, and today I am presenting a 21st century instructional redesign for Form 5 biology, specifically focusing on the topic of photosynthesis with the subtopic of light dependent and independent reactions. So, this project aims to transform a traditional lecture heavy subject into an active inquiry based learning journey using the flipped classroom model and advanced digital technologies. So, photosynthesis is often seen as a difficult and abstract topic for students because its biochemical processes occur at a microscopic level that they cannot be directly observed. Traditional methods like textbook reading and lectures frequently encourage rote memorization rather than deep conceptual understanding. So, this often leaves the students with persistent misconceptions, such as believing that plants get food from the soil only rather than through the light energy transformation. So to address these gaps, I chose the flipped classroom model, which allows students to engage with instructional videos at their own pace before class, which is especially helpful for both slow and also fast learners. By moving the lecture to the pre-class phase, we can dedicate valuable classroom time to interactive discussions and also hands-on simulations that foster the higher order thinking skills. So the journey begins before even students starts enter the classroom again. Yet, so in the pre-class phase, the students watch the interactive at puzzle micro lecture at home. So rather than just watching, they must answer the embedded check questions that provide immediate feedback. So as a teacher, I use the answers from the students in the ad puzzle and use the analytics to spot misconceptions like the common belief that oxygen comes from carbon dioxide and before the lesson even started. So I would also get the real-time data on the class understandings and allows the lesson to be tailored before the class starts with this kind of flipped classroom. So not to forget that all the expectations and also due date and tasks will be reminded in a medium called Google Classroom. So our journey continues in session 1 with an engage and explore phases where students observe the real world phenomena like oxygen bubble production experiments in water plants and give opinion about the reasons it happened by think, pair, share. We then move into a station rotation where students first use the PET simulations, kind of like a virtual science lab, and also augmented reality, which is AR. So the AR allows students to zoom into a chloroplast in 3D, turning the static flat diagrams into a visible reality that they can manipulate. So next session, they will observe the real experiment and record the data and then propose which specific biochemical processes that explain the bubble production rate. And then they even begin modeling the light dependent stage using the digital tools like Canva to internalize the molecular feedback loops or like a map of the process. So in session 2, teacher will start to ask students what is in their understandings and ask them to explain what is about the light dependent and independent reactions. In this point, the teacher will correct the misconceptions and clarify the light reactions and also Kelvin cycles. The teacher also asks students to write the chemical equation with a bit of explanations. So in this session, we introduce an innovative AI greenhouse challenge, which the students work in groups to design a commercial greenhouse, but they must defend their plan against a rigorous critique from Google Gemini, the AI. And this Gen AI is not just an answer generator, it acts as a sparring partner for the students to analyze the AI feedback, identify any scientific errors, and write evidence based rebuttals in Padlet. So it is not about getting an answer from a machine. It is about learning critically and argue with data that AI provided. So the final session focuses on synthesis, where the students will create a 5-minute video walkthrough to explain the relationship between light dependent and independent reactions. So all of these sessions, redesign explicitly targets all the three plumes domain, which are the cognitive, where the students analyze simulation data and AI outputs, and then the psychomodal, that the students construct the digital models and filming presentations, and last one, affective, where the students reflect on the importance of sustainable energy and teamwork. So this is the overview what will they doing. And by moving from a teacher centered lecture to a student centered digital inquiry, we haven't just taught biology, we have equipped students with collaboration, ethical reasoning, and critical thinking skills. And this is photosynthesis for the 21st century. Thank you for joining this learning journey.